Hi there, my name is Vajat Khalid and I am doing Masters of Electrical Engineering research-based program under supervision of Dr. Mohsin Jamil. So today I am presenting my case of Arduino-based solar power battery charging system for cathodic protection. So as you know, the name of the topic, it's basically a system for cathodic protection. So what cathodic protection is? So cathodic protection is used uh, for protecting the metal which is buried uh, under the earth cover. So here I took a specific case of the gas pipelines which are of distribution and transmission network of Sui Northern Gas Pipelines Limited, which is the largest integrated gas pipeline organization of the Asia. So, as we know that natural gas contributes the major chunk of energy source for the country Pakistan. So, Pakistan is uh, getting the maximum of energy through the natural gas. It's delivering the natural gas to the industries, to the power generation plants, to the strategic organizations, and the domestic household activities, and for commercial purpose. So, there are 11 regions on the network of the Sui Northern gas pipelines, and they are supplying natural gas to almost 5 million consumers, which include the industrial, strategic, and the bulk consumer, domestic as well as commercial. So the natural gas, the protection of the natural gas network is very critical. So as with the passage of time, when the network is laid under the surface, so with the resistivity of the soil, it gets corroded. So in order to protect that particular network, which is very important uh, for whole nation, like for the whole country and for our whole organization, we need a protective system which is already there. So in order to enhance the capabilities of that system, I have worked on that system that will work efficiently over there. So let's move on the outline of the project. So it has an introduction and the natural gas distribution and transmission network, the unaccounted for gas analysis, the CP stations and their working, the cathodic protection, and conclusion and future plans. So let's move on the next slide. So here the introduction, like here as I already mentioned, that the number of natural gas companies that is operating around the globe has distribution and transmission network. Like Sui Northern Gas Pipe is one of the largest distribution network with of the Pakistan, of the entire region, having the uh, network of 130,000 kilometers of pipeline, and it's serving around uh, 4,500 towns and villages, and the transmission network which is extended to 900 kilometers. The pipeline, as I've mentioned earlier, the pipelines and other underground structures are scattered, means that they are not confined to some single space. Like they are traveling gas from one city, as I can give example from the St. John's to Mount Pearl. The gas pipeline is traveling from that particular city to another city and within a city. So it's laid with all the other utilities like sewerage, like the pipeline network which is for water supply, and also the pipe which is laid for the protection of the electric cables. So gas pipeline is also laid with all the utilities. So in order to protect those gas pipelines, we have there is installed cathodic protection parameters at CP stations, which are uh, providing the parameters for protection of the gas pipelines. So the company the company in the case is having like 1800 CP stations, which are installed on the entire transmission and distribution network. So it's very crucial for the monitoring of all the CP stations are very crucial, so that we can have a better overview of what voltage and current they are supplying. So there's a problem with the like in the CP stations, like they are connected to the with the AC power which is coming from the hydro mains, like the in Pakistan is called WAPDA. So I have worked to overcome that issue. So my in my previous slide, there exists the transmission and distribution network slide. So I just want to let you people know that what is transmission and what is distribution network. So transmission network is basically the network which is of the higher diameter, which is supplying gas from one city to another, and having the sales meter stations and compression stations and valve assemblies, and the distribution network which is basically supplying gas within a city, which has like town border stations and district regulation stations and DRCs. So the major problem exists over there is as the gas pipelines are laid underneath the earth. So with the passage of time, they get corroded, which eventually have the potential of gas leakage. So which is the major issue which Pakistan government and Pakistan economy is facing. Like I am giving a quick overview of the unaccounted for gas, which is also called UFG, the gas which entered in the gas pipelines, but it didn't like build from the consumer. So it means that it just got vanished within the system, within pipelines. So how does it vanish within a system? It means like the gas is just evaporated, or like it's just leakage. There is leakage in the system, so which is due to corrosion of the gas pipeline. So there is a quick overview of the SNGPL UFG analysis. There's a 16 regions which are consuming gas. So here we can see that there's a difference of like 70 to 80 BCF, mainly due to uh, the gas leakages. So it in monetary aspect of view, we can see that there is a huge impact on economy of Pakistan. So it means that Pakistan is suffering a lot with this. Uh, like it's estimated that $1 billion is wasted in this. So in order to overcome this issue, I have like worked uh, on my project. So what basic cathode protection means? So cathodic protection is deploying the anodes under the surface near the gas pipeline. Basically the anode is a positive terminal. Basically there is exists a transformer rectifier units and the cables and the junction box and the gas pipeline. So gas pipeline is laid under the surface, and the rectifier is getting AC supply from the WAPDA. So the negative of the AC supply, which is like from 240 volts, it just stepped down to 24 volts, and the negative of that DC supply is connected to the gas pipeline, and the node which was deployed near the gas pipeline is connected to the positive supply. So these anodes sacrifice themselves in order to protect the gas pipeline. Like there is a closed circuit, as you can see over there. So it's just it's just passing the positive uh, to the gas pipelines, and negative electrons are flowing out. So by this, it will like protect the gas pipeline. So what we have in cathodic protection, like, is a transformer units, it's an anodes, it's a junction box, and it's a cable. So what I did, I like this is a brief overview of my project. Like, it's a remote monitoring electronic kit, and GSM based. So what my idea is, like, there's as you know that there is a maximum power outages Pakistan is facing. So as all the transformer rectifier units are connected to the AC supply, so there's a lot of load shedding in Pakistan. So there's a need of the device, of the need of time that we can like get ourselves out of that the old AC system. We need to develop a device and system so that we can get a solar energy uh, by installing a solar plates to the CP station, so that it can get rid of that load shedding which is causing disturbance. So like, whenever there is a load shedding, the CP stations get turned off, so they are not supplying the current to the gas pipeline, which results in loss of the gas pipelines and leakages, which is like damaging the network and also contributing towards uh, unaccounted for gas. So there is a need of device which charge the transformer rectifier units through the batteries, so that it can operate it round the clock, 24 hours and round the clock. So it is get itself over from that AC supply. So what in this diagram we can see that there is a rectifier, the transformer rectifier unit. There is a remote monitoring electronic kit, GSM base, the pipe and reference electrode and node base. So I'm also working on making GSM based the protection system, so that it will communicate the data uh, to the remote server, from the location to the remote server. From that we can also see the data of the CP station, whether this CP station is working or not, how much current is supplying to the supplying to the uh, gas pipeline, or what's the protection level of the CP station. So I'm also working on it. So the particular, like, in this project, like, there is solar panel, then DC-DC inverter, and the load, and the microcontroller, and the battery backup. So what is like this? The main part of it is power system, batteries, power conditioner, solar panels. The DC electricity generated by solar panels is eventually converted into AC power using converter equipment. So we have like the losses and complexity of power system increase over this convention. So this idea is especially helpful in production gas pipelines where a low voltage DC supply is required. So there are like many PV cell chemistries, battery of energy storage. So in this particular, like, for this I will take the batteries of the lead acid batteries, which are very useful and it's very efficient, and then the dry batteries. So in this product we have like charge controller, uh, because the battery charging method is insufficient. The sort of regulator is primarily responsible for preventing overcharging the battery. So I just my idea is like I am working on it to like have to charge the sufficient charge to the battery, so that it will get charged when there is a light, and it will stop charging the battery or overcharging the battery when there is sufficient charge on it. So there's something I have worked on to like protect my gas pipeline network and with it. So the charge controller to the precise voltage range needed to charge batteries convert the solar panel DC output. The charge controller units must operate within a specific voltage range and should automatically shut off the SPV, the specific voltage range. The charge controller automatically shut down when the quality of light